Good morning, students. Welcome back to the chapter Matrices. In the last session, we discussed about the special type of matrices. Those are symmetric and skew symmetric matrices. Okay, and we saw the examples. Yes, and today we will see some important concept which is related to symmetric and skew symmetric matrices. Okay, the first one is A into A dash into A, and A plus A dash. Dash means the transpose of the given matrix. If I make the product of matrix and its transpose of the matrix and the given matrix, and addition of the matrix and its transpose, then those all are symmetric matrices. Okay, and if I make the difference, of the A minus A dash, that is A minus A transpose, then it is a skew symmetric matrix. Okay, the third condition, students, it's an important one. Please consider here. If A is skew symmetric matrix, then A square is symmetric, A cube is skew symmetric matrices. Is it only possible for A square and A cube? No. You can raise the power whatever the number of times. A to the power 3, A to the power 4, A to the power 5, A to the power 6. Whatever the number of power or index you may raise. So in general, if A is a skew symmetric matrix, then A square is symmetric, A cube is skew symmetric matrix. That is, if the power is, means A is skew symmetric. If I multiply A into A, that is A square. A to the power 2. 2 is the even power. So, if the power of the matrix, skew symmetric matrix is even, then it is compulsory symmetric. Then, if the power is odd, that is A cube, A to the power 5, A to the power 7, like that. If the power is odd, then it is a skew symmetric matrix. Okay, let us see some example here, students. A equals to, what they mention, if A is a skew symmetric matrix, so I will write 0, 2, minus 2, 0. Is this a skew symmetric? So what is the shortcut method? Already yesterday in the last session only I said, if A12 is equals to minus A21, or minus A12 equal to plus A21, if it is possible or if it is exist for all non-diagonal elements, then it is skew symmetric, and diagonal elements must be 0 in the skew symmetric. So I applying the transpose for the given matrix A. So this row become column, this row become column. So it means 0 to minus to 0. So from these two I can recognize A dash equal to minus A, or A equals to minus A dash. Yes, it is possible. Okay. So what they mentioned, A square is symmetric, means if the power is even, means A into A. That time A square is symmetric, A into A cube, means it is a skew symmetric. Is it, students? Okay, let us see that whether it is possible or not. I give the statement for the certain result. We will examine that by particular example. Okay, so already A is here, so I want to get the A square. So A into A. So 0, 2, minus 2, 0, 0, 2, minus 2, 0. So just make the product of two matrices. Is it possible? Yes. It is also it is a 2 by 2 matrix. Again with the same matrix. The number of rows of the columns of the first matrix is same as the number of rows of the second matrix. So it is possible to find the product. Okay. 0 into 0, 0. 2 into minus 2, that is minus 4. 0 minus 4, that is minus 4. 0 into 2, 0. 2 into 0, 0. Okay. Minus 2 into 0, 0. 0 into minus 2, 0. Okay. Next, minus 2 into plus 2, minus 4. 0 into 0, 0. Minus 4 plus 0, it is means minus 4. So apply the transpose. A square transpose. So rows become column, column become rows. Again it is same. Therefore, A square equals to A square dash. If the power is even, that A square is skew symmetric. Yes, A equal to A dash. Here power is square, so A square equal to A square dash you obtain. So A square is symmetric. Okay. Next we will find the A cube. Next we will find the A cube. So A cube equal to A into A square. What is A here? 0, 2, minus 2, 0. And A square is already obtained. 0, minus 4, 0, 0, minus 4. So see the product here, students. 0 into minus 4, 0. 2 into 0, 0. 0 plus 0 is 0. 0 into 0, 0. 2 into minus 4, that is minus 8. Next, minus 2 into minus 4, plus 8, 0 into 0. 0. 8 plus 0, that is 8. Minus 2 into 0, 0. 0 into minus 4, 0. So, 0, 0. So, it is a cube. So, A cube transpose. If I apply that, I will get 0, minus 8, 8, 0. So, it is nothing but minus A cube dash. That is nothing but A cube. Or A cube dash equal to minus A cube. So power is odd here, therefore A cube is a skew symmetric. Power is even here, so A square is sorry, 1 second. Power is odd here, so the matrix obtained by the matrix multiplication, that is skew symmetric. Power is even. Okay, the power is even, so the matrix obtained, that is A square, is symmetric. It is an important concept, students. Keep in mind. So the next concept is, students, for any square matrix A, for any square matrix A with real number entries, A plus A dash is symmetric. A plus A dash is symmetric, and A minus A dash is skew symmetric matrix. It is a symmetric matrix. What is that? Already I mentioned the statement. For any square matrix, this is an important concept here, students. Okay? For any square matrix A with real number entries, A plus A dash is a symmetric matrix. A minus A dash is a skew symmetric matrix. So symmetric means if A is a matrix, if I obtain A equal to A dash, then it is the symmetric. If A equal to minus A dash or A dash equal to minus A, then A becomes skew symmetric. This is the main concept. Already you know in the definition of the symmetric and skew symmetric matrices. So the same concept we will have to apply here. Means if I apply A plus A dash whole dash, I should get the A plus A dash itself. Then it becomes symmetric. For A minus A dash, if I apply the transpose, I should get the A minus of A minus A dash. Then it is a skew symmetric. Okay? So let us see the result. So how will you prove here, students? The given thing, given A is a square matrix. What do you mean by square matrix, students? The number of rows and the number of columns of a given matrix is equal. That is the square matrix. Okay? For any square matrix dimension, either it will be 2 by 2, 3 by 3, 4 by 4, whatever the order. Okay? Let P equal to A plus A dash. They mentioned that A plus A dash is symmetric matrix. So I considered or assigned a value P. Okay? Now I am applying here the transpose for this result. P is also a matrix of the order A plus A dash itself, not the different order, because we are using the equality of the matrices here, students. Okay? So P dash equal to A plus A dash whole dash. Okay? So P dash equal to A dash plus A dash whole dash. Okay? So why? Because we have the result A plus B whole dash equals to A dash plus B dash. Already we learned in the transpose of the matrix. This is the property for the transpose of the matrix. Okay? So here A dash plus A. Why it is? Because already we have the result. A transpose whole transpose is equals to the matrix itself. Okay? So what we obtained here, students? P dash equals to A dash plus A, or P dash equals to A plus A dash. Why it is? Because A plus B equals to B plus A. The addition of the matrices follows the commutative law. The addition of the matrices with the same order follows the commutative law. So A dash plus A or A plus A dash. Therefore P dash equals to P. P dash equals to P. What is P? P equal to A plus A dash. So P dash equals to P means the given matrix is A here or P here. So the transpose of the matrix is same as the given matrix. Therefore P is symmetric. So what we assigned for the P here, students? A plus A dash. You may take it as for reference, take it as equation number 1. Therefore from 1 we obtain A plus A dash is a symmetric matrix. Symmetric matrix. Got the point, students? What I did here? Just I assigned the P equal to A plus A dash, then applied the transpose by using the properties of the transpose and commutative law of the addition. We got the result. Okay? So for the next we will consider I will consider Q equal to A minus A dash. Observe here, students, what I will proceed here. So now let Q equal to A minus A dash, consider as the question number 2. So now applying the transpose. Okay? So Q dash equals to A dash minus of A dash whole dash. So what will get here? A dash minus of A. Okay? So we can't write A dash minus A is equals to A minus A dash. The subtraction of the matrix will not follow the commutative law. Why? 2 minus 1 is 1. 1 minus 2 is minus 1. There is no equality of the entries. So we can't write that one. So instead of that, I can take minus common. So we'll get A minus of A dash. So Q dash equals to minus Q from the equation number 2. Therefore, from referring the equation number 2, Q equal to minus Q dash, that is A minus A dash is A minus A dash is skew symmetric matrix. So important concept here, students. Please go through the proof. Okay. Okay, next statement, students. Any square matrix can be expressed as the sum of a symmetric and a skew symmetric matrix. Okay. Any square matrix can be expressed as sum of symmetric and skew symmetric matrix. Okay. See you, students. Let A be a square matrix. A be a square matrix. Then we can write. A equals to 1 by 2 into A plus A dash plus 1 by 2 into A minus A dash. Okay. So already we know for a square matrix A is a square matrix here. So I can make the transpose of this matrix. Then if I add the transpose of the matrix and the given matrix, A plus A dash is the symmetric. And if I make the difference, that is A minus A dash, that is a skew symmetric matrix. Already we know that result. Okay. Let us state that we know that if A is a square matrix, then A plus A dash is a symmetric matrix. A minus A dash is a skew symmetric matrix. Already we know this result. In previous proof I proved this one. A plus A dash is a symmetric, A minus A dash is symmetric for any given square matrix. Okay. So, and we know that another property in the transpose of the matrix, that is A is a matrix, A dash is the matrix, that is transpose of the matrix. If A is the symmetric matrix or a skew symmetric matrix, then Ka dash is also symmetric or a skew symmetric matrix. If A is a symmetric or skew symmetric, then K into A dash is again a symmetric or skew symmetric matrix. This is also one property. If A is a symmetric or skew symmetric matrix, then K into A, then K into A is also then K into A is also symmetric or skew symmetric matrix. Okay, already you know that result. Therefore 1 by 2 into A plus A dash is also symmetric. And 1 by 2 A minus A dash is also skew symmetric. Therefore any square matrix can be expressed as follows. That is, A equals to 1 by 2 into A plus A dash plus 1 by 2 into A minus A dash. This is the result, friends. You may get the one question from this concept. Okay, just go through this one.